Okay, friends, we are going to go ahead and go over these answers here. Let's see what we've got. Let's see here. Distance is measured in meters. Absolutely correct. Time is measured in seconds. Yes, mass is measured in grams, and temperature is measured in degrees Celsius. Again, obviously, they can be measured in different things than this, right? We've got things like degrees Fahrenheit or feet, inches, right? But again, these are the units that we're going to use most often in our class because these are generally accepted among the scientific community and the international community. Again, a lot of our measurements in the US are different than the rest of the world. If a unit is a combination of other units, that is, yes, a derived unit. Think about the word fundamental kind of means like the basics, whereas derived, yes, that's going to be a combination. Excellent job on that. Once you have your notes open, go ahead and raise your hand. I will be asking for raised hands from 100% of you later, but if you've already got them open, go ahead and just raise your hand now and leave your hand up. So again, you do need to be working on your notes during class if you want attendance. You'll always get notes credit regardless of when you do it throughout the trimester. You also get 3 chances on them. But if you want attendance, then they need to be done during class. So you need to be here according to the attendance report, and you need to actually be doing your notes during class, participating. I do check the timestamp on them. I do check that you passed with a 60% or higher. You should always pass because I always give you enough answers to pass. So you should always pass your notes in class if you also want attendance. Again, you always get notes credits regardless, but if you also want attendance, you can go ahead and make sure that you're doing them in class. Please do not share contact info. Please make sure you are participating often and well and behaving appropriately. And don't forget that these are being recorded. We are on day 4 out of 60 here. So we are taking a look at finishing up our first week of trimester 13. Congratulations. Hopefully yesterday you got a chance to take a look at the recording. All right, so we had a recording that started you off on your Unit 1 project. You only had to take a look at slides 1 through 6. You did not have to do the entire project. It is a paper airplane project, so you will need to make 3 paper airplanes out of any paper that you have lying around at home. If you have something that prevents you from making a paper airplane for some reason, a physical limitation or some other limitation, please let me know because I have a lot of solutions in my back pocket to help you out. So there are no excuses. You just need to communicate with me. As always, that's always my expectation. I'm very flexible if you communicate with me. Otherwise, I cannot read your mind, especially from here. Okay, so make sure that you watch the recording if you haven't already, and make sure that you start your project. I recommend if you haven't done it already, make sure you start it over the weekend. Make sure you have 3 paper airplanes with your names written on them, ready to go, and that you've taken picture of your paper airplanes with your names on them. All right. Yeah, Lena, I don't think you would have been able to do all of it quite yet because I have some specific ways that I want you to do things like the graph, but that's fine. If you've done as much as you can, then you can just be checking your answers as we go throughout the project throughout Unit 1. So I know a lot of it you can do on your own since it's your first project, but again, just make sure you're checking it against what I'm asking you to do when the next instructions are sent out, okay? Awesome, everybody. So go ahead, give me a smiley face or an emoji or a yes in the chat if you understand that you should have begun working on your project yesterday, but if you didn't yet, please work on it over the weekend. Just need to know that you understand you have to be working on your projects. You cannot pass this class without doing projects correctly. Excellent. All right, today we're going to be taking a look at the metric system, so let's go ahead and jump into that. An announcement first, though. If your name is up here, right here, right, which I know some of you are in class right now. If your name is up here, you do need to complete STAR 360 math and reading assessments. So this is how our school tracks your math and reading skills throughout the entire school year. However, since you just started for trimester 3, my 6 people down here, since you just started for trimester 3, you actually have to take it at the start and end of trimester 3. I apologize. I know it's not the most fun. They're each only about 20 minutes though, so get it done. They're also worth 5% in all of your classes. So even in my class, which is a science class, you still get 5% just for getting them done, okay? So taking a look here, these sessions are already on your live class schedule. Again, if you're a new student starting this trimester, you'll see them on Monday for reading at 1 p.m. and Tuesday for math at 1 p.m. Now, on the other hand, if you're an old student or a new student, everybody, regardless, will be required to do STAR 360 at the end of the trimester to see over the entire school year, how did you end up doing in terms of improving in your math and reading? And we're tracking to make sure that you are in fact improving, or if you need other interventions because you're not improving, okay? No worries, Lexi. Glad you were able to make it in. These will be proctored during normal classes because, again, everybody will be required to do them at the end of the school year. So that'll be May 24th in period 2, so in 2 months for reading, and period 3 on May 26th for math in 2 months. Okay, so again, if you're an old student, don't do them yet because it will not count. All right, so old students, you have to wait until the end of the trimester again, and then you will get your grade there. Okay, perfect. All right, let's go ahead and take a look here. So we are taking a look today at using significant figures to measure an object with precision. We're going to identify the SI prefixes, and we're going to complete basic conversions using the SI prefixes, all right? So we are going to be working on the 1C notes, and that means I need your 1C notes open. So especially if you just joined us, please go ahead and open up your 1C notes and raise your hand. I know a bunch of you have already raised your hand because I asked you to do it at the start of class. So here's the link if you are one of my students. Here's the link if you are one of Ms. Cruz's students. And again, try both links because one will work, one won't, or otherwise go to your grades tab. So what I want to know in the chat box, would you rather measure a long distance race in inches or miles, and explain why? Go ahead and tell me in the chat, would you rather measure a long distance race in inches or miles, and explain why? Awesome. I see Angelina working in the chat. I see Lexi in the chat. Edwin. Yes, awesome. Exactly. Miles would be way easier, right? A mile is really big, so it's really easy to say, oh, it's 1 mile, 2 miles, 3 miles, whereas inches is such a tiny measurement that you would have to be like, oh, you have to go this many inches. It would be like hundreds and hundreds and hundreds, thousands of inches, right? It would take a really long time to measure that. Awesome. What about, let's try this one on the right then. Would you rather measure a ladybug in centimeters or meters? Would you rather measure a ladybug in centimeters or meters, and why? Yeah, if you choose the inches for the race, you're crazy. Yeah, saying something's like 500,000 inches means nothing, right? As opposed to 3 miles. 3 miles means something, right? Yeah, you would much rather measure a ladybug in centimeters, and why? Explain why. Yeah, centimeters are much tinier, right? So it's easy to say, oh, it's like 2 centimeters, 1 centimeter, as opposed to it's a very, 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 very small amount of meters, right? A small part of meters. You ran 5,000, right? Awesome. Okay, so what this is just explaining is that different units are useful depending on the scenario. So let's go ahead and talk a little bit about that. So today we're going to be taking a look at measurements again. But we need to talk about how we actually do measurements in real science classes. So measurements can only be as precise as the tool being used. So again, if I tried to measure a ladybug in meters, I would not be able to get exactly how big that ladybug is because a meter is just not precise enough. Okay, same thing if I were to try to measure a race, right? Measuring in inches is too precise, right? So we want to have our precision of our tools kind of match up with what we're actually trying to measure, as well as we need to make sure that when we communicate what our tools are measuring, that we're communicating them correctly, okay? So this brings us to a topic called significant figures, okay? So significant figures are the digits. The word digits means numbers, the individual numbers, okay, in a measurement that communicate how precise a tool is, okay? So significant figures should always include all of the digits that you do know from your tool, plus one estimated digit, okay? So taking a look here, okay, what do we absolutely know that this pencil is at least? Tell me in the chat box in centimeters, this pencil must be at least what? We absolutely know that it is what? What is the known digit here? Tell me in the chat. Yeah, we know it's at least 6 centimeters. And then if I were to estimate it, right, it's a little bit bigger than halfway. So 6 point what would make sense? 6 point what? All right, we're going to estimate one digit. So 6 point what would make the most sense? The answer is actually up on the board. But yeah, 6.8 or 6.7, right? 6.6, right? A little bit more than half. So taking a look here, again, we include all the known digits, which in this case was just 6, plus an estimated digit, which in this case is 0.7 or 0.8 or 0.6. Okay, again, everyone might estimate a little bit differently. But that tells us that our ruler is precise enough where I absolutely know it's at least 6 centimeters, and I know that it's probably a little bit over half past 6 centimeters. Go ahead and give me a smiley face or an emoji in the chat box if that's beginning to make sense. All the known digits plus one estimated digit. Excellent. Smileys, emojis. Thank you, Angelina. Thank you, Tati, Amari, Erica, Edwin, Lexi, Lena, Jaime, Alexander. Excellent. Okay, so this is going to be both number 2 and number 3 in your notes. Please make sure that you fill them both in with only what you see in the red box. Make sure you spell it correctly. And raise your hands for number 2 and number 3. Number 2 is precise. Number 3 is estimated. You have 30 seconds to go ahead and do that. Let's go ahead and actually work on this together. So to determine the length, we need to know all the known digits. Again, we're practicing significant figures. Okay. Oh, no worries, Joseph. Okay, if you need to, just take pictures of the answers. Okay, so take pictures of the answers and then just make sure you get it submitted before 1 p.m. before I upload the recording. And that way I can still give you attendance. So from now on, just raise your hand once you've taken a picture. Okay, if your notes are slow. All right, let's go ahead and take a look here. So we're going to use significant figures. So we want to determine the length. We want to know all the known digits plus one estimated final digit. So let's go ahead and take a look here. First off, for this one, I know that this red line is at least how long? What is my known digit? At least how long is this? Excellent. I see Lexi. I see Lena. Angelina, Itati. Yeah, let's use units. This is centimeters, by the way. This ruler is in centimeters. Sorry, there we go. Yeah, so we know it's at least 1 centimeter. Now let's estimate the next digit. So taking a look here, this would be 1 point what? What would you estimate this is? It's a little bit less than halfway, maybe a little bit more than a fourth of the way. So 1 point what would make the most sense here? What's our estimated digit? Again, include units, don't have naked numbers, put some clothes on them, include units. There we go. I see Angelina. I see Lena, Callie, Itati, Lexi, Lena. Yeah, again, your estimation might be a little bit different, but sure. Like I think most people are saying 1.3 centimeters. Excellent. All right. So again, we have a known digit, which is the 1, and an estimated digit, which is the 3. Now let's go ahead and take a look at a tool that's more precise. Okay, so this one is actually more precise because it actually has little lines in between each centimeter. So right here, I know that this line is at least 1 point what? I know it is at least 1 point what? Take a look at how many little dashes it is past the 1 mark. No, not 1.3. It's at least 1.2, right? You can see here, right here's 0.1, here's 0.2. So it's at least 1.2, but we still need an estimated digit. So 1.2 what? Take a look at the line, all right? It's a little bit past halfway. So this is 1.2 what? Go ahead and tell me in the chat box. Give me one more estimated digit. We know it's at least 1.2. Now let's estimate the last digit. It's a little bit more than halfway. So 1.25 would be exactly halfway. So we want it a little bit more than that. A little bit more than that. 1.3 is too far. So we need an estimated digit. I need a number right after this 2. So I need it to be 1.2 something. Again, we know it's at least 1.2, so just give me that last digit. 1.2 what? Yeah, so 1.26 or 1.27 or 1.28, all of those would make sense, right? So I'm just going to put a 7 right here. Smiley faces, emojis in the chat box if that makes sense. Again, we absolutely know it's 1.2. And then we're just estimating one more digit. It's not quite to 1.30, so I would say 1.27. Awesome. Yeah, so any of those would be correct. 1.26, 1.27, or 1.28, as long as it's a little bit past halfway. So taking a look here, this is going to be the answers for number 4 and number 5. Again, this first one was less precise. So it's only 1.3 because our estimated digit is the 3. For this one, we already knew it's at least 1.2, and one extra digit would be That's 7. So 1.27. All right, so this one was more precise. All right, this is going to be number 4, number 5. Go ahead and answer both of those. You need to put the number in the first box and the units, cm for centimeters, in the second box. Only put the abbreviation. Do not spell it out. So this is number 4 and number 5. Raise your hands when you are done. You have 40 seconds to work on that. Again, units for both should be written as cm. Number 6, you need to be able to do on your own. Okay, I'm going to go ahead and start you off though. So number 6 says, using significant figures, what would be the best measurement of the leaf using the ruler provided? Okay, so again, you have a known digit. All right, so everyone should know that this is at least 5 something. All right, so again, you have a known digit. That's your known digit is 5. But you need one more estimated digit. So take a look at that estimate. No, do not put answers in the chat. Do not put answers in the chat. All right, that's also incorrect. So double check your answer. All right, so do not put answers in the chat. Sorry, I know we're new to this, so just remember, anytime you see on your complete on your own, don't put it in the chat. Okay, so on this one, go ahead and you have your known digit. Now you just need one more digit. One more digit. So take a look here. All right, you need to think about which of these only has one more digit after the 5 and which of them is closest to the correct estimation. Go ahead and work on number 6. Go ahead and raise your hand when you have completed this. Again, this is a complete on your own. Do not put answers in the chat, but if you want to check your answer, go to the Q&A area. All right, you have 30 seconds. Go, go, go. If you want to check, I'm in the Q&A area. So, as we took a look at in our brain stretch, we saw sometimes it's helpful to have smaller or larger versions of a unit. And so the International System of Units, one of the reasons that scientists love this, the SI system, is because it has smaller and larger versions of units. Okay, so taking a look here, if you have a base unit, which could be meters, liters, grams, even seconds, okay, so all of these are a lot of the units we've been talking about. The SI system, you can actually change the prefix, the start of it, and that means something different. Okay, so a decameter is actually 10 meters. A hectoliters is actually 100 liters. And a kilogram is actually 1,000 grams. Smiley faces or emojis in the chat box if that's beginning to make sense, right? So you take your base unit, and based on its prefix, you can make it bigger or smaller measurements, okay, or units. Same thing, you can even go smaller, right? A decimeter is 0.1 meters. A centiliter is 0.01 liters. And a milligram is 0.001 grams. All right, so again, based on what you're measuring, you might want to use a different type of unit just to kind of scale it up so that it makes sense, right? Again, we don't want to measure, taking a look here, we're not going to measure a marathon in meters because we would have to say, oh, it's a 42,200 meter race. Instead, we're going to use kilometers. Kilometers is a much bigger measurement, a bigger unit, and so we don't have to say as many numbers. So we could just say 42.2 kilometers, okay? Now, let's go ahead and talk a little bit about how you get from one type to another. So this is going to be what we call conversion ratios. So to convert from one type of unit to another type of unit, you can use what's called a conversion ratio. Now, conversion ratios in reality always equal 1. I know that it might not look like it, but let's talk about why they always equal 1, okay? For example, 1 minute is the same as 60 seconds, okay? So if you take 1 minute and divide it by 1 minute, what do you get? Anything divided by itself just equals what? Tell me in the chat box. 1 minute divided by 1 minute equals what? 1 minute divided by 1 minute equals what? It does not equal 0. Anything divided by itself equals what? It equals 1, right? So 1 minute divided by 1 minute just equals 1. Same thing, let's say if I do 60 seconds divided by 60 seconds, what does that equal? 60 divided by 60 equals what? It does not equal 60. Anything divided by itself always equals what? It still equals 1, exactly. So 1 minute divided by 1 minute equals 1. 60 seconds divided by 60 seconds equals 1. It always equals 1, okay? But here's the thing. We just said that minutes and seconds are interchangeable. Instead of saying 1 minute, we could actually say 60 seconds. So we can actually put 1 minute over 60 seconds, and these are the same time. Acknowledge for me in the chat box that you understand that 1 minute and 60 seconds are the same time. Yes or no? Do you understand that 1 minute and 60 seconds are the same exact amount of time? Yes, so this is actually still dividing the same thing by itself. I know that mathematically it looks like it's a 1 over 60, but units matter. So 1 minute divided by 60 seconds is the same amount of time being divided by the same amount of time. So mathematically, this actually technically still equals 1. Okay. Again, this is something that we're going to review a few times, so don't freak out if you're like, that's blowing my mind right now. Go ahead and just give me a smiley or an emoji if it's beginning to make sense. That because they're technically the same amount of time, when you divide them, they still equal 1. They still equal 1. Okay, so these are what we call conversion ratios, and we can also flip them. We can say 60 seconds over 1 minute. It's the same time over the same time. That still equals 1. And anytime you have conversion ratios, you can throw them into equations, and they can help you to convert from one type of thing to another type of thing. Let's go ahead and actually try it out, because I know theoretically you're like, okay, that's a lot, but let's go ahead and actually practice it. So let's take a look at this question. What is 27 seconds in milliseconds? What do I have a number for here? Do I have a number for seconds or a number for milliseconds? That's what I'm going to start with. You always want to start with the number with something you already know, which is a number that you have. So which of my units has the number, the seconds or the milliseconds? Which thing here has a number, the seconds or the milliseconds? Where's the number? I see Angelina in the chat. It's not a trick question. Which one has a number attached to it, seconds or milliseconds? Let's go, let's go. I don't want us to run out of time. I need participation in the chat. There we go. Thank you, Callie. Thank you, Lena. Yes, seconds, exactly. So we can see here that we're going to start with 27 seconds. We always want to start with what we know. And so this is what's called our known. Okay, it's what we know. It's what we're going to start with. So I'm going to go ahead and write out 27 seconds up here. Okay. Now, conversion ratios, okay, are always fractions. And so I'm going to put that 27 seconds into fraction form by just putting it over 1. Anything over divided by 1 is still itself, so that doesn't change the fact that it's still 27 seconds. Go ahead and give me a green check, orange X if that makes sense. So I just put it over 1 to turn it into fraction. It doesn't change its identity. Okay, dividing by 1 does not change an identity. Excellent. All right, so it's in fraction form now. Cool beans. All right, so now we need to think about our conversion ratio. Okay, so what we know here is that 1 millisecond is the same as 0.001 base units, which in this case is seconds. And again, we can make them into a fraction because all fractions for conversion ratios equal 1. So we can put them all into fractions. So I can put 1 millisecond over 0.001 seconds. Again, it's the same amount of time, so it's fine for me to put them over each other. Or I can flip it and put 0.001 seconds over 1 millisecond. Again, they're both the same amount of time. I can put them one on top of each other. That's totally fine. That's allowed. That's where conversion ratios come from. But we need to figure out which conversion ratio should I use. Okay, so here's the deal, guys. Currently, I have seconds in my numerator on top, and I want to get rid of it in the next step because I want milliseconds. I don't want seconds. So where do you think I should put it in the next step to get rid of it? If I want to divide out seconds, should I put it on the top of the next step or the bottom of the next step? All right, where do you think I should put that? Go ahead and tell me in the chat box. If I want to get rid of seconds, all right, I'm going to put it on the opposite side. It's currently on the top. So where should it go in the next step? Yeah, I'm going to put seconds on the bottom here. Okay. And what I'm going to solve for goes on top. And taking a look back here, what am I solving for? What am I solving for? Take a look at our question. What is 27 seconds in what? What am I solving for? Yeah, we're solving for milliseconds. So I'm going to put milliseconds on the top. Okay. All right, so based on this, which conversion ratio do you think I should use? Go ahead and point for me on the board. Should I use the one on the left or the one on the right? Okay, again, I need a conversion ratio that has milliseconds on top and seconds on the bottom. Use your colored pointer and point for me which of my two fractions here fulfills that. Which of my two fractions has milliseconds on the top and seconds on the bottom? Milliseconds on the top, seconds on the bottom. Green, move over. Green, that has seconds on the top. I want milliseconds on the top. Move over, green. Move over. There we go. Yes, perfect. We're going to go ahead and actually use this fraction here. Okay, so we're going to go ahead and use this fraction here where we have 1 millisecond on top for every 0.001 seconds. All right, go ahead and give me a smiley face or an emoji in the chat box if that's beginning to make sense. Again, we're going to practice this a few times, so don't panic if it doesn't make a ton of sense yet. It just takes practice. Okay, so we have our equation set up. Now we just need to go ahead and multiply it. Anytime you multiply fractions, it's super duper easy. You just multiply the tops together and then multiply the bottoms together. So on top, we should have 27 times 1. And on the bottom, we should have 1 times 0.01. So what do I get on top? What is 27 times 1? What is 27 times 1? Yeah, it's just 27. And on the bottom, what is 1 times 0.001? Excellent. I see Lena in the chat. Need more people. What do we get on the bottom? What do we get on the bottom? 1 times 0.001. Yeah, you just get the same number, so 0.001. Okay, what I want you to do, go ahead and grab a calculator. And anytime we have a fraction is just division in disguise. So take the top number and divide it by the bottom number. Go ahead and tell me in the chat box, what do you get? 27 divided by 0.001. Do it on a calculator, on your phone, on a computer. 27 divided by 0.001. Thank you, Erica. Thank you, Angelina. Yeah, perfect. You get 27,000. All right. And units here, let's go ahead and take a look at our units. So we had seconds on top here, but on the bottom in the next step. And so that actually gets rid of seconds. And the only units I'm left with are milliseconds. And that's exactly what I was solving for. So my units down here should actually be milliseconds. All right, this is going to go ahead and be the answer to number 7. Go ahead and raise your hand when you have that filled out and ready to go. Work quickly because we still have 2 more problems to go through. I think we're going to go a little bit into passing period, so please work fast. We're going to try one more practice one together, and then I'm going to help you set up your last one. The last one, though, you have to finish on your own. So make sure you have a calculator because the last one you have to finish on your own. Okay, so what is 4,780 grams in kilograms? Again, which thing do I have a number for? Grams or kilograms? Which thing do I have a number for? Grams or kilograms? Work quickly in the chat. Excellent, Angelina. Excellent, Cody. Yeah, we have a number for grams, and so this will be our known. This is what I'm going to start with. So over here, I'm going to go ahead and plug in that we know we have 4,780 grams. Okay. Now, grams is on the top here. In the next step, I want to get rid of it, so I should put it on the opposite side of the fraction. So where should it go? If it's on the top here, where does it go in the next step? Yes, on the bottom. And what goes on top? What am I solving for? This is going to get rid of grams. But what goes on top? What am I solving for? Take a look back at your question. What am I solving for? Yeah, we're solving for kilograms. So kg should go on top. Point for me on the board, which of my 2 fractions here, 1 kilogram over 1,000 grams or 1,000 grams over 1 kilogram, which of those is set up correctly? Go ahead and point for me on the board. Which one is set up correctly? Yeah, excellent. The one on the left. Perfect. So this is the one we're going to use here. All right, so we're going to go ahead and say we have 1 kilogram over 1,000 grams. All right, let's go ahead and multiply these together. Okay, so on top, I have 4,780 times 1. What does that give me? Tell me in the chat. 4,780 times 1, what does that give me? Yep, same number. We should get 4,780. And what about on the bottom? 1 times 1,000, what does that give me? 1 times 1,000, what does that give me? Perfect. Yes, it gives me 1,000. All right, so we have a fraction here. Fractions are just division in disguise. Grab a calculator on your phone or on your computer and tell me what is 4,780 divided by 1,000. What is my final answer here? Excellent. I see Juan Carlos. Let's get some more people. I see Lexi. Awesome, Lexi, working on those units too. I see Itati. Awesome. Get your answers in the chat. 4,780 divided by 1,000. Yeah, this is going to be 4.78. Now, taking a look up here, the units that I had left over were kilograms, which again was exactly what I was solving for. So the correct answer here is that your units should be kilograms. Smiley faces, emojis in the chat if that's beginning to make more sense. Smiley faces, emojis if that makes more sense now that you've had a second chance to try it out. Cool beans. All right, this is the answer to number 8. Go ahead and raise your hand when you have this saved, and then I'll explain the last question. All right, I will help you get the last question started. I know this is a new process, so don't be nervous. We'll work on the last one together, but you do need to finish it on your own. Okay, perfect. Now, this last one, you need to be able to finish on your own, but I'm going to go ahead and start you off here. All right, so we have 16 meters in hectometers. Which thing has the number? What do I start with? Do I start with meters or hectometers? Which one has a number that I know? Meters or hectometers? Yeah, I know this one, right? So 16 meters is what I start with. That's my known. Okay, so over here, I'm going to start off with 16 meters. Now in the next step, I want to get rid of meters. It's on the top right now. So in the next step, I need to put it on the opposite side. Where should it go in the next step to get rid of it? Perfect, yes, on the bottom. And on top is what I'm solving for. So tell me in the chat, what am I solving for? Take a look at our question. What am I solving for? What units? Yeah, we're solving for hectometers, so we'll put HM on the top. So point for me up on the board, which of my two fractions is set up correctly? 1 hectometer for every 100 meters or 100 meters for every 1 hectometer? Which one is set up correctly? Awesome, I see 3 people on the board. Let's get some more participation up there. You can also tell me in the chat, left or right, which one is set up correctly? Which one is set up correctly? There we go, perfect, getting more people up there. Awesome, yes, perfect. This one, yes, on the left. So 1 hectometer over 100 meters, 1 over 100, right? So now we just need to go ahead and set this up. So we have 16 times 1 on top, 1 times 100 on the bottom. What do we get on top? 16 times 1, what do we get on top? Yep, we get 16. And what do we get on bottom? 1 times 100. 1 times 100. Awesome, yes. All right, do not put any answers in the chat, but the last step is that you will divide the top by the bottom. And then the units you should have left over should be hectometers. All right, go ahead and answer number 9. Again, do not put answers in the main chat. If you want to check your answer, I will be in the room chat. So all you need to do now is just finish this up, 16 divided by 100, and make sure your units have hectometers. This is going to be number 9, 30 seconds to answer number 9. If you want to check your answer, I'm in the Q&A chat. You go ahead and just answer that last question, understanding that you need to be working on your projects. Again, we did start that yesterday, so if you haven't done that yet, make sure you start it over the weekend. Make sure you submit your notes now. That way I can also give you your attendance, and I will see you all later. Have a wonderful week.